What's up, guys?
Are we on yet? Oh, there we go.
Hey.
Hello. There we go.
What's up, guys?
Not much. Oh, shoot. Are we almost done?
What's going on?
Nothing much.
We're just waiting.
I guess so.
Okay.
Are you there? Are you there, Danielle? Can she hear us?
Oh, is that what happened?
I don't know. I haven't heard her. Oh wait,
She's
maybe
probably
she's
trying
gonna try.
something.
Yeah.
Yes, we can.
Can you hear me now?
Yes.
Yay!
I don't know why my computer does that. It's so stupid. Okay. Hi, guys.
Hello.
Hey.
So, this quiz is really short.
Ooh, yay.
Sweet.
You took it already?
No, I just opened it.
Oh,
I
okay.
did the homework already, but
Gotcha.
Do we need to
Yeah.
open our SPSS?
let me see.
Mine was not working at all today. It wouldn't let me log in.
Oh, no.
Yeah, it says compute the residuals for the math self.
Yeah.
Just one, it looks like. Just one SPSS.
Okay.
Yeah, mine is not even letting me log in. Here, I'll show you the screen.
Okay.
Yeah,
That's what came up.
I've been having issues with it too.
Well, let's see if I can pull it up.
Yeah.
I might go pause really fast here. We'll see
Okay.
if it kicks me out.
Oh yeah. This is not responding.
Is it not opening at all?
Nope, mine isn't working.
Mine isn't either. Maybe we should email her.
Yeah, because if we need, can we do it in Excel?
You know, I tried that, and I couldn't get any of the programs that were required for it.
Oh.
And I even tried, like, saying that I was from a different class.
Mm-hmm.
It didn't even give the options then. So I don't know what's going on. But I'm going to take a screenshot of the...
Yeah.
Okay, so... And then I'll send a picture to her.
Mine still hasn't come up yet, so
You didn't get an error though or anything?
not yet. We'll see. Thinking about it, whether or not it's gonna let me on. I got it. Wait.
Oh.
Maybe. Hold on. Yeah, mine works.
How come yours works?
Yeah.
I'll just
No,
write
we're-
her and say that one person's is working.
You'll all just have to trust me. Ha 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 ha.
She has all the power.
I could steer you so wrong. Just kidding. Yeah, that's super weird. Well, let's see if I try to open this. Let's see if they'll open that for me. No, I got it. Okay.
Weird.
Very weird.
Okay, I'm gonna insert picture. And then email that to her.
Alright. Well, do you guys want to get started and then we hit the SPSS? We can skip it or I can give it a go and
Sure.
share my screen. That way everyone can tell me what I'm doing wrong, alright?
Yeah, that works.
That sounds good.
Alright. I gotta remember how to do it because I did the homework like last weekend.
You're on top of this.
Yeah.
I think this is our last like group meeting that we have to turn in, so it's great.
Yeah. All right.
Okay, so I just sent it. Hopefully.
Oh, did you get it to work?
Mine isn't working still, no.
Okay.
But anyway, we can move on and worry about it later.
All right,
What's up,
let's-
Danielle?
Oh, we lost Irvin.
Oh, we didn't even notice.
Where did he go?
How long has he been gone?
Ah!
I don't know. I just went to make sure it was still switching screens, you know? And he just gone.
Oh,
Oh,
wait, he's back.
Here he is.
Sorry about that.
Where'd you go?
My computer was going on the fritz, and so I had to restart it.
Oh. How long were you off for?
I don't felt like maybe like 2 minutes. I don't know.
We didn't even know.
We were kind of surprised.
Like, what the?
Yeah,
Okay.
I couldn't type anything to you guys to let you know because my computer was all frozen, so I had to.
Me.
All right. Well, I can read number 3 if everyone's there.
Go ahead.
Okay. the true linear regression equation y equals BO plus B1 x, where I forget what they're technically called, so BO plus and B1 are unknown. What are the null and alternative hypotheses for B1?
Is it the third one down?
Yeah, that's what I put.
Yeah.
We don't know anything about the other ones yet.
Right.
Yeah.
Okay, I can read the next one.
Go for it.
Go ahead.
A residual is what is left over after doing simple linear regression. Is the difference between the observed value y and the value predicted by the regression line. Is the difference between BO and B1? Beta. Okay. Depends on the independent variable. And I'm pretty sure it's number 2, yeah.
Yeah, I think.
Yeah.
Alright.
Good. Okay, I'll read the next one. A plot of residuals supports using linear regression when you see a pattern in the residuals are all positive, you see a megaphone shape in the residuals look normally distributed with zero mean. It's the megaphone, right?
I thought it was the last one.
Yeah, it should look kind of like random. It shouldn't be a megaphone, because that means that the variances are wrong.
Right. Okay, so it's normally distributed?
Does that mean it's random?
Right.
Yes? Yeah, okay, yeah. Wait.
With zero mean?
Hold on.
What does that mean, looks normally distributed?
Okay, let me look at residuals.
Is that the E?
It says QQ plot of the residuals.
Right.
Once the residuals have been calculated in SPSS, we can assess if they are normally distributed using a QQ plot.
Okay. So then normal means random?
Yeah, I think it's zero mean, that one, because it shows in the residual plot for the crocodile, whatever, it's got a zero mean.
Oh,
Yeah.
okay.
I'm trying to see where it's... So it would be the last one?
Yeah. Normally distributed with zero mean, so normally distributed just means randomly distributed, right?
Yeah.
I think that's what we're getting at. I mean, I see the picture.
Yeah, the picture is just like spots everywhere.
Yeah. And I think the megaphone shows like a pattern, like to the side, like it's closer on one side.
Right, and you don't want that, right?
Right. So I think it's the last one.
Yeah, so if it supports our linear regression, then it's zero mean and normally distributed. Okay,
Yeah.
Sounds good.
That's that's the closest one anyway. Okay.
I can read the next one.
Okay.
Let's see. Compute the residuals for the math self-efficacy data using software. Use the confidence data as the explanatory variable and the score data as the response variable. Which statement best describes the residuals?
Oh boy.
That's
math self-efficacy.
Use confidence data as the explanatory variable and the score data.
Wait. Sorry. It says to test for this. Sorry, this is going back to the question before. If we want to know if there's a linear relationship between x and y, to test for this, we need to determine if the slope is different from 0. If the slope is 0, then that suggests that there is no linear relationship between the two variables.
Right.
So if the slope is not 0, that suggests that there's a linear relationship between the two. So, and we want to find. What were we asking for?
Wait, should it be the residuals are all... Wait, hold on. It says, a plot of residuals supports using linear regression when... Oh, wait. Supports using linear regression when it's random. So it says this residual plot shows random scatter. If linear regression is appropriate, then the residual plot will show no patterns. So, obviously, it's not the first one. It's not the third one. And it might be the residuals are all positive.
But the picture, it has negative values.
Yeah.
Oh, yeah, that's right. So maybe it's still the last one. Because it
Yeah.
can't be the first or the third for sure.
Yeah.
Because the megaphone and the pattern show that you've done it wrong.
Okay. It just makes me, because if the slope is 0, then that suggests there's no linear relationship between the two variables. Is that linear regression?
Regression. Linear. Yeah, if linear regression is appropriate, then
Yeah.
the residual plot will show no patterns and will consist of random scatter.
Okay, so the slope would be 0.
Yeah, if there is a pattern in the residuals, it suggests that the linear regression is not appropriate.
Okay. I just wanted to double check. I just found that and I was like, oh, I don't know. Okay. The
That's
next
the
one.
only one that it could be because the other ones are false.
Right.
Yeah.
Okay.
Okay, so let me try and share my screen for this one.
Okay.
Can you see it now?
Yes.
Okay. So I go to Analyze, Regression, Linear. And then the dependent. What are we trying to find out? Sorry, could someone read the question again?
It says, oh wait, hold on. It says, compute the residuals for the math self-efficacy data using software. Use the confidence data as the explanatory variable and the score data as the response variable. What statement best describes the residuals? The residuals are between -40 and 25. The residuals are all negative. The residuals form a linear pattern. So I'm pretty sure it can't be the linear pattern because when you do the residuals, it's... What? Well, I don't know, actually.
Well,
So
I
it's
guess we have to
that
shows.
confidence rating is independent to, or the score is dependent on the confidence rating, right? That's what we're trying to figure out.
Yes, so, okay, the score data is the response. Yeah, so that's the dependent.
Okay.
Score data is dependent. Explanatory variable is the confidence.
I have to share a different screen.
Mm-hmm.
And I think it won't form a linear pattern unless we're doing a QQ plot.
But don't we need to? Oh no, yeah, okay.
So I don't think we have to do the... So I think the last one is eliminated just from that, possibly.
Okay, so here's what I got.
Mm-hmm.
Hold on, what am I doing here? 1 second.
Compute the
But it wants
residuals.
the confidence interval?
No. It wants to know if the residuals are all negative or if the residuals are between about -40 and 25. So we're just computing the residuals. Let me check that out.
Yeah, so it should be that second one, right?
Wait,
I mean, the
residuals. Here they are.
Dari, did you do analyze, regression, linear?
Yeah.
Okay.
I think I need to make a graph of it, don't I?
Yeah, let me see here.
Just the residuals, though, so...
But from here, does it look like that first thing?
What?
From here, from this residual statistics, does it look like it's that first thing? Is that what we're supposed to know? The residuals are between 40 and 25?
Maybe that would be the confidence interval, but I don't know.
No, you gotta make it... I'm sharing the wrong screen, but hold on.
Okay.
I hate this.
Are you trying the scatter dot?
Yeah, so what I'm doing now, I've got my residuals here.
Right.
And so where in the homework it said the y-axis is the residuals, right?
Mm-hmm.
And then the x-axis is the score, or the dependent variable, right? Or is it the independent?
X-axis, hold on.
Independent.
Independent? Okay.
Yeah.
Okay. Hold on. Okay. So now I've got this scatter plot. It's running it right now. And I'm sharing the wrong screen again. I hate this. present to everyone. Yes. Okay. It's still running. Hold on. Okay.
Okay.
So there's our graph.
Okay.
Right.
And then what is it asking for again?
Compute the residuals. Which statement best describes the residuals? The residuals are between about -40 and 25.
Yeah.
The residuals are all negative, or the residuals form a linear pattern. I don't think they should form a linear pattern.
They don't form
No,
a linear
They
pattern.
don't. Not at all.
They're definitely between 40 and 25.
Yeah.
Yeah.
-40?
Yep.
Yep.
Okay.
40 on the graph. Okay. Based on the
Holdings.
QQ plot, what can you say about these residuals? Okay, gotta make a QQ plot. Hold on.
Mhm.
Analyze graph. Legacy dialog. Box plot, right? Yeah.
QQ plot.
Mm.
So that would be, oh wait, no, it doesn't give instructions. You just have to remember.
Dang it.
Mm.
I think it's, it might be under compute. Wait, I don't know. We can't see your screen, or your mouse.
Again. Dang it. Hold on.
I think I got it. Not 100% sure.
So the variable is the residuals, right?
Right.
Yes.
And then what was on the y-axis? The dependent or independent?
Independent.
Independent. Okay.
Yep.
Sharing the wrong screen again. This one. Share. Ah!
Huh.
Whoa.
Something went wrong. Hold on. QQ plot. I'm gonna look it up.
I have analyze, descriptive statistics, explore, and then plot. Does that mean
Analyze,
anything?
explore.
Actually, QQ plot is just like you go to the descriptive statistics and it's just on the bottom of the list right there.
And then do explore, plot.
Okay, hold on. I heard like 3 of you. 1 second.
Okay.
Let me go back. Okay. So can you see what I see now?
Yeah.
Oh, wait.
Analyze.
Descriptive statistics.
Okay. QQ plot.
Explore. I have explore and then plots. I don't know.
So the
There-
dependent is my residuals, and then the factor list is the confidence.
For the
Residuals go in the factor box.
The residuals go in the factor box.
Yeah, that's what I have.
Okay. What goes in the dependent? The score?
I kind of think you only need to put the residuals. Isn't this the one where you only need the one thing in the box and that's it?
no, because it says. Well, wait, that might be true because if you
Yeah.
just put the just use the residuals.
Okay.
Yeah, because it says you want the default choice, so skip that.
We
Move the
don't-
variable representing your residuals, usually res-1, to the y-axis box. Then move your independent variable into the x-axis box for the blank data. This is the head length. When you click OK, and then it should pop it up.
That's the box plot. I mean, that's the scatter plot.
Residual plot.
Okay. Once the residuals have been calculated in SPSS, we can assess if they are normally distributed using a QQ plot. We simply make a QQ plot of the residuals. Just the
Right.
residuals, yeah.
So you only need to put those in the factor box.
I clicked plots. Now what?
And just put the
Oh, we
residuals
can't
in
see what you're doing.
Oh man. How about now?
No.
Nope. Wait, now we see your mouse.
Yeah, we saw it for a second. There we go.
You see it now?
Mm-mm.
No.
I also have that we need to check the unstandardized residuals in the dependent.
But
Um,
that's not an option.
Yeah, did you go into the, is it save?
That's a different. That's not explore. That's not what we're doing.
Let me try SPSS one more time.
Let me try something. No. Hold on.
Oh, we can see it now.
You see it now?
Yeah.
Oh, yeah.
Oh, SPSS just started.
Woohoo!
Mine just started opening.
It says click standardized values. Is that what you said?
I have unstandardized residuals.
Let's try that. Mm-hmm.
In the book, all it says is just make a QQ plot.
Oh, you guys can't see it. Dang it, my moment was ruined. Hold on. Ta-da!
Yay!
Oh, yay!
Okay.
All right.
Looks normal to me.
Yay,
Yeah, that
normal.
looks normal.
Oh, wait, but this is D-trend normal QQ plot unstandardized residual.
No,
Not.
that's weird. Normal
we just
QQ plot.
Yeah.
So I would say the residuals are fairly normal.
Yeah.
All right. Okay, I'll read the next one. Okay. Wait, Danielle, are you still there?
Oh no, what happened?
Uh-oh. Maybe SPSS froze on her. You okay out there?
Is she there?
The laundry soap fell
Oh.
and is now like all over.
Will you pick it up? Oh gosh.
Oh no.
Okay, well while we're waiting for Danielle, I will be right back.
Okay. Oh wait, I think mine just opened too. Is Danielle back?
I don't see her. You and I are doing the variance part of our project, right?
What?
You and I are doing the variance portion of our Gatorade project.
I wrote down that I have the.
Can't remember if it was you or someone else.
Oh goodness. I have the next part. The. Where did I write it down? forget what it's called.
So the next part.
The next thing we're doing is. Why didn't I write it down somewhere better?
It's make the inference and take action.
Yes. That's it. Take action.
Okay, so you and I are going to be working
Are you guys still there?
on that one.
Yeah.
Sorry, my internet just went out, so it was stupid. Okay, do we lose Kaylee too?
She had to run and go do something.
Oh, okay. Okay, well, I'm back. So, we didn't get number 8 yet, right?
No.
No.
Okay. There is a linear regression between x and y. A linear relationship between x and y. That one is, right?
Mm-hmm.
Okay. And then the residuals are normally distributed, yes.
Yes.
The variance of error term is constant for all values of x. How do we find that?
It says how to check is to make a residual plot and then to make sure there's not a megaphone shape.
Oh, yeah.
There wasn't, right?
Right.
Okay. Let me just go back and check. The x values, the x's can be considered as known constants.
Known constants?
And this one's a little tricky because it says to check for that, it says it cannot be checked directly. And what you hope to see is that the x's should be measured accurately and precisely.
So if it's a normal plot, like a residual plot, there's no pattern, then the x values are measured without error. That means we measured them correctly.
I'm back. Sorry.
All right.
Can you hear me now?
Yeah.
Okay, good. Did we lose Irvin too?
I don't think so. He was just
Oh,
there.
there he is. Okay. Alright. Sorry, my computer, I think it's SPSS slowing it down. But, okay. So I'd say that the x's are measured without error.
Yeah.
And then I think the observations are independent.
Yeah,
Okay.
those two can't be checked.
Huh?
Because those are the only two that you can't really check to make sure.
Yeah. So would we check them or not check them?
Isn't it if our plot is random, then the values of x were measured without error? 'Cause
Yeah.
if we had a megaphone, then it would mean that we did something, we didn't measure them correctly or something, right?
Yeah.
So we
That would
can
make
check.
sense.
We can check that one, right?
Yeah.
Yeah, that would make sense.
I think they're all satisfied. Otherwise, it wouldn't tell us to make
Yeah.
a confidence interval.
Yeah, except for the middle one, right?
Wait, which one?
Mhm.
The variance of the error term is constant for all values of x.
Didn't we check that one?
I don't know. I didn't check it, but I don't
'Cause
know. It's backward to me.
Didn't
Variance?
Irvin you say? How do we check that one? It was like
Which one?
the middle one, the variance of error term.
Variant? It says to make a residual plot and then to make sure there's not a megaphone shape in it.
Right, and there wasn't. So we should be able to
If
check it.
there-
Yeah, we should check that one off.
Oh, so all 5 of them are checked?
I think so. Because it wants us to make a 90 or a confidence interval, and the only way to make a confidence interval is if all the requirements are met.
Oh. Okay. Okay.
Okay, so I think B1 was, isn't it? Okay, hold on. I gotta check the reading.
The slope and the regression. Like some weird horror movie.
Okay, so the independent variable. Hold on. So we figure out for the next one, what is B1, the estimate for the slope?
Yeah, and that's in our chart of information. It'll be under the B statistics.
Under
Is that word?
unstandardized coefficients?
Yes.
Yeah, on standard, yeah. Under the
Yeah, that's
B.
weird.
And is it the confidence rating one or next to constant?
Say that again?
Is it next to the constant or next to the confidence rating? Or like, is it the top or the bottom B?
I think it's the bottom B.
Because you're taking the constant and then whatever is below the constant. So those two numbers in the B bracket.
So
then,
B1 is the bottom one.
Okay.
yeah, B1 it will be the bottom one, and then B's beta 0 will be the top one.
Okay, so our bottom one is 12.695.
See if I got that one.
Okay.
Yep, that's what I got.
Okay. And then I gotta make a confidence interval. So analyze regression linear. Deep. Okay. So analyze regression linear, and then our dependent was a score, right? Independent was the confidence rating.
No, I think you put the residual for the dependence, and then is that? Hold on, let me check. Just make sure.
No, because it says in here, just move the dependent or the response variable.
Okay, yeah.
And then you check confidence interval under regression coefficient. I think
get-
so.
Sorry, go ahead.
I think that's what you do.
Yeah. And then, like, you click on statistics, and there should be a button that's like a little square that says,
Confidence intervals.
yeah, confidence interval. Type it in, then bam.
And we want the 95th, right?
Yep.
Okay. Okay. So I got, and is it the top one or the lower one?
For
For the confidence interval in the little box, is it the bottom one? Like
Yeah,
the,
yeah. You take the you take the bottom one.
okay. So then our confidence interval is 10.674. Is that an option? Let's see if that one's close. 14.715. The closest
Yeah.
one is the top one.
Yeah.
Yeah.
9.574? No. 9780.
You
Yeah.
got 10.674.
Yeah.
Okay.
10.674. I think it's the top one.
Oh, it is. My bad. Yeah.
Yeah.
I just double checked.
Okay.
9.574.
And then the p-value is 0.000. So we would reject it, right?
Mhm.
Right.
And it's the second option.
Right.
Okay. So that means that there is sufficient evidence to conclude that the regression line is 0, or is not 0, right?
Yeah.
Because we're proving the alternative. So it's the third one?
Yep.
Okay. And then, sorry, I'm doing all the reading. Somebody else
No,
go.
you're good.
Or
Oh,
the
for number 10, we put the 9.46, right?
No, 10.708.
Was that right?
Yeah.
so on that number 11, they have the t value equals 12.476. Where did they get that number?
It's in the coefficients box. Only I got 12.424.
Yeah, that's what I
My
got
numbers are a
too.
little off for some reason, and I don't know why.
I know,
But
so I'm thinking, is our number 9 gonna be?
Oh, sorry, really quick, Danielle.
yeah.
I just checked the book, and it says for the confidence interval, you want to look at the line that's on the constant. So it's going to be the confidence the confidence intervals that are on the top row.
Oh, the top?
Yeah.
Okay.
For
Well
some
then,
reason, I think on the bottom.
is that the same? But for
It's
the
close because it says 9.574, and one of the answers says 9.46 and 27.657.
yeah,
So
but
is
the
it
B
B?
one, but number 9 is still 12.695, right?
Yeah, that's what I got.
Okay.
So we use the bottom for the B1, but for the confidence interval we use the top.
And let me check really quick. Let's see.
No, it says to use the bottom. Use the bottom one. Let me go to my homework and see. Yeah, you use the bottom one, I think.
For the
For the confidence interval. Because it says that if you use the top one, it doesn't make sense. This is illogical.
Oh, I see. I just didn't see. Okay, I should have probably finished reading that section.
Yeah. No, I think you use the bottom one.
Okay.
So it is 10.708.
Okay.
Okay, so then we reject it. P-value is less than alpha. And then there's sufficient evidence to conclude the regression line is not 0. So, for the equestrian, whatever, crocodiles, which variable is the dependent variable? That was in our
The
reading.
Yeah.
head length?
Yeah, because the body length determines the head length, or was it the other way around?
Let me read.
Body length is the dependent. Yeah, it's the body length that is the dependent.
Is the dependent, yeah.
The
Wait,
head length is independent.
I thought it was the other way around. Hold on.
Yeah, I'm always getting that mixed up too. I don't know why.
I know, these are so
Much.
confusing.
Okay, move your dependent variable to the x-axis. For this equestrian crocodile data, that is the head length. So, oh, your independent variable is the head length. So body length is the dependent. For another lesson, I feel like they switched that up.
They might have.
Mhm.
Okay, so head length is the dependent, right? Is what you said?
Head length is body length is dependent.
Yeah, the independent variable is the head length. So the dependent variable is the body length.
Okay. Yeah.
Okay. So since the 99% confidence interval for this data is those numbers, what can you say about B1?
Yeah, I'm. Can't. It's not.
It's not the first one.
I don't think
Yeah.
so.
And it's not the second one because you don't say there's a 99% chance.
Gotta be the last one, I guess.
How do we know that? There is insufficient evidence to reject the null hypothesis.
I guess if you use, let's see. Let's see what happens when I change the linear into 99%. Look at the p-value.
You're 95% confident. The length of the head increases by 1 centimeter, then the mean increases in the body length.
Still showing 0.000. It would still reject it because it's less than 0.5.
Although the first one kind of makes sense, because it's saying that the mean, since the confidence interval does not contain 0, there is sufficient evidence to conclude that V1 is not equal to 0. And a confidence interval tells you they're confident the true slope of the regression line relating to the head length and the body length is between those two numbers. So if you were saying that they were equal to 0...
Ah, I see.
Yeah.
I mean, I don't know if that's right, but I mean, it kind of makes sense.
That makes a lot more sense.
From this information, can we decide if we reject the null hypothesis from the confidence interval?
No, we do that based on the p-value.
Right.
So,
What data is this? Which
The
crocodile?
green crocodile data.
yeah.
Let me pop it up.
Because B1 is equal to the slope, right?
Yeah.
So,
Yes.
if you were saying that the mean was 0, you would need to have a slope of 0, wouldn't you?
Yeah. There would be no slope. Yeah.
I don't know.
That makes sense.
That's right. Do that one. But don't submit it yet because we missed number 8.
Ooh.
I just went for it. Sorry.
So the 13 was the top, the top one, or
Yeah.
14?
14 was the top one, yeah. But 8 was wrong, so
Okay.
one of those boxes doesn't get checked, I guess.
Let's see.
I think it's the observations are independent.
Like, did you get like a complete 0, or did they give you partial credit?
It's just 0, yeah.
I don't know why we. I don't
mean,
know why
if you miss it, it's still a 93, but...
Yeah. Well, I don't know, guys. Like with the questions that have like multiple answers, I don't know why it's like.
Oh, Kaylee
Yeah.
texted me. Sorry. I have to send her an invite.
Let's see.
See if she can come back.
No, I still got it wrong.
Yeah, I still got it wrong too.
Oh well.
Well, I'm gonna stay on. You guys are free to go. Who has the assignment for this weekend for the group?
Me.
And
Well, I'm doing the take action part, but does that include the other part too?
yeah, because I'm doing making the inference
Okay.
part.
Let me see what's due this weekend then. I'm gonna stay on. Sorry, that's what I was gonna say. I'm gonna stay on and help Kaylee finish. Hold on. Okay, so this weekend, making inference and take action. Oh.
Yeah.
What the?
And are we each going to do pick a different slide for the PowerPoint then? On our
Yeah, I think.
part?
Yeah, because that's due not this Saturday. It's due on Thursday. So next
Yeah.
Thursday.
Yeah.
The make inference action thing.
No, the
No, that's due Saturday.
PowerPoint.
Oh, gotcha.
Yeah.
Okay, let's see.
I don't know. So maybe you two could, I guess turn it in together, or maybe help the other person turn one in. I don't know.
Yeah.
Yeah. I don't know what
See.
it looks
One or
like
two
yet.
paragraphs discussing whether or not your data meets or fails to meet the requirements for your hypothesis test. If you use the QQ plot or box plot, include those in your document with explanation. Also, write out any formulas you are using to show that your data meets the requirements. Statement of your null and alternative hypothesis, state these in words and then in symbols. State your alpha level, give your test statistics and its value, state your p-value. Based on your p-value and alpha level, state whether or not, yeah, we know that, and then finally state your conclusion.
Okay.
Sounds fun.
And then number 12, one to two paragraphs describing the action you suggest based on the results of your study.
Ugh.
All right.
Are each
Like
of
me,
us
huh?
doing a part of that, or is it
Not
just
this,
one?
this part is Irvin and me.
Miranda.
Okay.
This is one's gonna be hard. I understand how to word it all and everything, but I just don't know how to put it all in a paragraph. It's basically all I'm
Don't
saying.
send the paragraphs.
This is our data.
I
This is our
totally
data. And we reject it, and yeah.
exactly. No, that's exactly what I did for the describing the data. It was total BS, and she accepted it. So I wouldn't send the paragraphs. I just get
Say that live.
yeah. Well, I thought about it. I knew all of our grades depended on it, but we still got 100 on it. So, I mean, I just wrote the same thing.
You all throw in some fancy English words in it. And
Yeah. Basically, I was like, well, the data shows da 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 da. You know, I said, oh, our mean was this. I just get the facts down, what are the different values, which do in SPSS or Excel maybe.
Yeah.
I wouldn't sweat the paragraphs though.
okay. I can explain it all in sentences, not necessarily a paragraph, but.
Yeah. All right.
Did you guys get a grade for that?
Alright. Sounds good.
A grade?
Grade for that?
Yeah.
Did it go through? Okay, good. I just
Yeah.
wanted to make sure.
Yeah. It came up.
Okay. And Kaylee, I'll help you finish the quiz.
Okay, I was kind of like, trying to figure out how I could get back on, but I just ended up watching the video kind of as you guys are going. So I don't know how much I got, but hopefully, I don't know. I mean,
All right.
Yeah, I'll help you finish it. But I did a minute ago, so.
okay.
All right.
Okay.
We'll see you later.
See you guys.
Thanks, guys.
Bye.
Okay, so what number did you get to?
So I got to, so I kind of caught the tail end. So I got like 11, 12, 13, and 14, I
Okay.
think. But I wasn't sure about 7, 8, and 9 and 10.
Okay. Well, 7 we found were fairly normal.
Because they were on the QQ plot.
Right, and it was the graph showed it.
Okay.
8 we all missed. So I said it was all of them. I think Miranda and Irvin checked the observations are independent, so they didn't check that one, sorry.
But that
But
one was wrong.
yeah, so I think it might be the bottom 2 you don't check.
Because we don't know. Those are never for sure.
Right. So I think that's what my thinking is, but I don't know for sure. Sorry about that.
That makes sense. Because when you read through the textbook, it just says there is a linear. It only says the top 3 are for sure knowns.
Right.
So that would be the last 2 would be the x's are fixed. Okay. And the observations are independent that we don't know. Yeah.
Yeah.
Okay.
And then number 9 we found was 12.695.
Okay.
And then 10 was the first one, the 10.708.
Okay.
And then 11 was the second one. We reject it because of the null hypothesis.
All right.
It's
Because it's
less-
not 0.
Yeah, or it was 0.
Oh, what? Oh, okay. So we reject it. Okay. And
And
then
then-
for 12, did you get there is sufficient evidence to conclude that the slope of the regression line is not 0?
Yep.
Okay. And, for 13, because I heard you guys talking about this too. When you think of it, if you were to find like a fossil, it's most likely that the body would be destroyed, but the head would be intact. So you can figure out what the body length is based off of the head because it's more likely the head would be found anyway. So
Smart.
yeah, that's how I thought of it, and I got it right the last few times. So I don't know. But-
Yeah, that's what we found too. It's the body length.
Okay. And then 14 is the first one, right? Since the confidence interval does not contain 0.
Yep.
Okay, cool. I'm going to submit.
Thank you.
We'll see if it works.
Yeah, will you let me know if that's the right answer for 8?
It's the right answer.
Oh, nice job. Okay.
Okay,
cool.
well, thank you.
Yeah, no problem. See you Thursday or Wednesday, whenever.
All right. Have a good one.
Okay, bye.
Okay.